to the fourth edition of the Cross Hybrid. It's meant to be an exploration of the possibilities between lecture and a performance, and sometimes a workshop, as much as we could get into the form of a workshop in a short 1 hour. We mainly deal with programming language of pure data with sound, because this is the two of the thing that I do the most. And sometimes we try to, or most of the times, I try to pose certain concepts to think about, or just to provoke, or just to put something to try to put music making or the programming or the any kind of manipulation of the media into creative context. So, and today I'd like to go into something that I did some time ago, and I sometimes I return to it, and it's a tool made in pure data. And maybe for a start, I want to talk a little bit about the randomization, or the role of randomization as I see it and as I feel it in my effort to make music or make sound, or for example, in the first hybrid, I talked about that I'm realizing that what I'm looking for in programming or in making pure data patches and other things similar, I try to find something, a sense of aliveness in the programs or patches that I make. So I also like the idea of generative programs that create sound or music, and I was also saying that I'm realizing it's not that today this aliveness is getting a different term, which I termed as that I'm looking for a performative quality of a code, or of something that is being coded, so a program or a patch. So what are the performative qualities of something that is made and functions and is somehow released to make things without my or our intervention, for a certain degree, of course. And so this connects to this idea that, or connects to what we're seeing here, what I'm going to explain or open up a bit. It connects to the idea that we have these powerful computers, and we have ability to program and write code and create all kinds of different machines that create sound and so on. And that it seems to me, or it still seems to me, that we can program little animals that would make sound and musical structures, so rhythmic and melodic and sonic structures that most of the time musicians try to create by hand. So somebody would like to is making a song that has a certain structure that is somehow predictable. So all the, let's say, put it very kind of like an example, a lot of pop songs actually follow certain rules of the structure, how they're made, how they're developing in time. They have certain parts that are different, and they have certain rhythms that are somehow they're. I feel that this kind of structures can be put into abstract form, so to kind of mathematically describe them, then throw them into sound and music making machines, so these machines would generate this kind of sound. I'm not trying to say that we can definitely make a machine, a program that would generate perfectly humanly felt songs. But I am provoking this idea. So my long time idea is to create something that is going in this direction, and so the idea is to work on modules, like parts of maybe a big machine that would work on different aspects of music making process. So one of them is making a beat, a rhythm, a rhythmic pattern. And so about a year ago, a little more than a year ago, I had an opportunity or time to actually try something which started as a prototype and is still quite prototype. It is it's quite useful somehow. So I was able to use this recently, and it's not quite there. But the idea is to have certain data that is that helps generate rhythmic patterns in real time, but with variations. So the idea was to give to the program, if we're talking about a rhythmic pattern that consists of 64 units, or in other words, 8 bars. Each bar is 4 units. So this is like the basic 4 quarters, time signatures, time signature, and then we have this, and I can give as somebody who's trying to control this a little bit, that I don't give like exact times when the basic will kick and when the snare drum will hit or when the hi-hat will hit, but I give probability value. So I would say, okay, at this point in time, bass kick should kick 100% every time. At this point, it should kick only 50% of probability, so 1 to 2, or so that you don't give like definite decisions where some sound happens. You give a probability. So at some point, there's only 20% of probability that sound event occurs. And this is what where I started, and on the basis of this, the pageant we're looking at is somehow developed. And on top we have a kind of like a standard timeline, a loop that is running in time, is like looping. And this is just like a counter of time. And then we have what we can see up here is 4 let's say containers that contain probability values, and in each of them we can define certain the best way is to actually see things. So in the first this part, we there's on top is this a thing that in data is called an array and a table. And then there is just a volume control and the length of the sample. So in this top, it also says DD on the top. As you see, this whole block is being repeated 5 times. They have different names. BD stands for bass drum, SD stands for snare drum, hi-hat, open hi-hat, and FX, something undefined somehow. So, and for example, we'll take a ton of all others. And make this